If you want to get started with Blazor and learn all the fundamentals needed to start building applications in Blazor, you are in the right place. We'll get started with learning what Blazor is, we'll learn about the project structure and what each file does, and we'll go into the different render modes in Blazor and how to create web apps with the CRUD operations. So just keep on watching. Well, welcome to Code the Future, this is Alan by the way, and I help you learn C# and .NET on your own. Without losing any time, let's start with our first section. In this video, we'll get to know Blazor, its main characteristics, and what it is used for. Blazor is the modern front-end web framework part of the .NET platform, which is based on HTML, CSS, and C#. This framework allows us to build our entire web app from the front-end to the back-end using a single development stack, sharing code for common logic on the client and server. A key feature of Blazor is its component-based architecture. A Blazor component is a usable piece of web UI that encapsulates both its rendering and UI event handling logic. You can create your own components, but Blazor also provides many built-in components for many different use cases. In Blazor, components can be rendered from both the server and the client in order to deliver the best possible web app experience. Depending on the interactivity required, different components or even pages within the same application can be rendered from the server, the client, or even a combination of both. All the render modes and their specifications we will see in detail later on in the series. It's important to know that Blazor is not limited to web applications, but it's also capable of building native mobile and desktop apps through a hybrid approach known as Blazor Hybrid, blending native and web technologies. So I have just opened up Visual Studio here. Let me just create a new project. And I'm going to need to find the Blazor web app template. Let me just see what we have here. Okay, so the first one we got is the one we need. Click on next. I'm leaving everything as default here, the project name and its location. And here we can see that we are using .NET 8. I'm going to leave everything as it is. The interactive render mode is selected as server by default. We're going to see later on in another video all of these render modes in Blazor, but for now we're just leaving everything as it is, and the interactivity will leave as it is as well per page and component. And let me just create our first Blazor web app. Okay, our project is created. Let me just run our project here. Click on start without debugging, and let's see our default project. Okay, so here's our Blazor web application. We have a home page here just stating hello world, welcome to your new app, and then we have a navigation menu on the left, or like a panel here where we can navigate to the counter page. We just have a counter that we can increase by clicking on the button, and we also have a weather page that just loads some boilerplate weather forecast data. So right now in this video we're just gonna go back to our project and see what each file in our project contains. Every C# based .NET project has a project file with a CSProj extension. Here are usually inputted properties and settings that determine how the project will be built and compiled. We have specified here the .NET version that we want our project to use, and this other line enables nullable reference types. And here is specified that implicit usings are enabled in this project, which automatically includes common namespace imports based on the project type. This feature basically reduces the need for repetitive using directives at the top of every file. Let's now go to program.cs file, which is the entry point of our application. Let's just start from the top. This line creates a new instance of Web Application Builder by invoking the static createBuilder method. Then we configure services for the application. Here we're adding eraser components and interactive server components. And in this line here builds the web application instance, or basically our app. And we have now an app. And then we write the middleware for a bunch of different things. This line adds middleware to redirect HTTP requests to HTTPS. Then here we add middleware to serve static files like HTML, CSS, JavaScript from the web root directory. This line adds middleware to protect against cross-site request forgery attacks. And here we are mapping the app component as the root component for Razor components, enabling interactive server rendering mode. And in the end, we run the application, which is now ready to listen for and to handle HTTP requests. Let's go now to the www.root folder, which contains static web assets that are served directly to the client's web browser. Here we can have HTML, CSS, and JavaScript files, as well as images or other static assets. In the properties folder, then we have the launch settings.json file that contains settings related to how the application is launched during development. They can be modified to suit the specific requirements of the project or different development environments. We have as well the app settings.json file, which contains configuration settings for the application that you want to be part of your app at the runtime. Things like connection strings, various application settings such as logging levels, default values for certain parameters, or even third-party service configurations. We have an app settings.development.json file as well, which stores configuration settings specific to the development environment. And just like this, we can create files for the other specific environments, like for staging and production as well. Let's go now to the components folder, where we have all of the components of our app. In app.razor, we have the root component, where we can see the root HTML document, the Blazor router, and the Blazor script tags. Inside the routes.razor file is defined the routing configuration for the application. It basically specifies the mapping between URLs and the corresponding components or pages to render. All of our pages are inside our pages folder, as we can see here. We have the home, the weather page or component. Now let's go to the layout folder, which contains the layout components. Layout components define the overall structure and appearance of our application's pages. We have the main layout.razor file, which is the main layout component used by our application. And it usually defines the overall structure of the application's pages, such as the header, the navigation, the footer if needed, and so on. And then the nav-menu.razor file contains the markup and code for the navigation menu component. Lastly, we can see that we have the imports.razor file, which is actually a special Razor file that contains the using directives that import namespaces globally for use across all of our Blazor components within the project. This way, we do not need to specify the namespace in each individual component file. So this was an overall introduction of the files in our project and what they are used for. Just as a quick reminder, if you have been getting value so far, please like the video and subscribe to the channel for more content. Now, back to where we left off. Let's start by navigating to the components folder in our project. Here you'll find various Razor files, as you can see, And these files in Blazor define reusable components that make up different parts of our application's user interface. Now, what exactly is a Razor file? Well, it's essentially a blend of HTML and C#. Razor is a markup syntax that allows us to define rendering logic like conditionals and expressions alongside our HTML markup. If we navigate to the Pages folder, we'll find the pages of our application also written as Razor files. For example, the home page is defined by the home.razor file, or we can call it the home component. Here we see the page directive specifying the route for this page. This ensures that the home component is displayed when the user navigates to the root of the app. Additionally, we have the page title component, which sets the title for the current page displayed in the browser tab. So, except for the components that we can create, we also have built-in components, just like this page title component. The rest of the file is normal HTML that defines the content for the page. If we try to run our application, we'll be redirected to the root of the app, which is our home page. Now, let's take a look at the counter component. It is located in the pages directory as well. This component renders a simple counter that increments each time a button is clicked. Notice the page directive specifying the route for the component, and the render mode directive enables interactive server rendering. And we'll actually see in a separate video in more detail all the render modes in Blazor, but this basically makes possible the user interactivity in our web app. What we have next, each time we select the click me button, the onclick event is fired, the increment count method then is called, which is declared in our code block, where we write most of our C# code, and this method increments the current count field, which is defined above inside this code block as well. And then the current count is displayed inside the paragraph element using C# syntax with the @ sign. If we navigate now to our counter page, we can use the menu on the left to go there. We can see how the counter works. Each time we click the button, the current count is then incremented, and we can see its value displayed on the screen. But how do we use components in specific parts of our application? Well, we just add an HTML style tag with the name of the component. For instance, to add the counter component to the home page, we simply include a counter element in the home.razor file. We can run the application, and we will see that we have a counter in our home page as well. Components can also have parameters which allow you to pass data to the component when it's used. Component parameters are defined by adding a public C# property to the component, which also needs to have a parameter attribute. We can then specify a value for a component parameter using an HTML style attribute that matches the property name. So we can define a parameter on the code block in the counter component to specify how much it increments with every button click. We are defining a public int increment amount property, and we're setting its initial value to 1 so that it increases with 1. And we need to change the increment count method to use the increment amount value when incrementing the value of current count. Now in home.razor, we can update the counter element to add an increment amount attribute that changes the increment amount to, let's say, 10. But you can put here any value, any integer. We can run the app again. And we will see that the home component now has a counter that increments by 10 each time we click the button. We can go and see in our counter page that the counter increments only by 1, since these are two different counters, and 1 was the default value given to the property of the component. And that concludes our brief overview of components in Blazor and how to use them. Web UI elements can trigger different kinds of events in response to user interactions, and we'll see how to handle these events in order to create dynamic and responsive user interfaces in our Blazor applications. Some of the common UI events that we'll cover are click events, mouse events, keyboard events, form events, and focus events. Event handlers in Blazor are attached to HTML elements or Blazor components using special attributes, but we'll see now how it works. Okay, so let's go back to our project. We have here just like a simple Blazor web app project just created, just like in previous videos as well. And let me just open up the Solution Explorer. So in our counter page, we basically see in the previous videos as well that we have actually handled an event. In this component, we have handled here the onclick event with this event handler right here. So basically the onclick event is specified in the button element with this onclick attribute, and it has received a value of the method that we would want to basically be called as soon as this event is fired. So after we have the button is clicked, this method is being called, and we have specified the method in our code block below, just like we saw in the previous video. And if we click on the button, this increases the current count variable, and it is basically displayed here above. There's also another way to handle these events. We could use a lambda expression in the value of this onclick attribute, and we could just increase the current count field with this increment operator, and this would do the same thing that this method does. We usually do it with methods, but if it's something pretty simple or short, we could use a lambda expression. Let me just test it here. So this still works just the same way. Now we're just going to see some other type of events that we can handle in this video. Let me just take firstly an example of a form event. I am taking the oninput event, which basically is an event that is handled as soon as we input some data in an input tag. We'll see how this works. I'm just gonna take like an input element, single tag. I'm just giving it a type of text, basically just to specify that it receives text. And here we can just write this @ sign to get the event, to write the event attribute, which has a name of oninput, and we'll give a value to this attribute, like handle input, which will be the name of the method which we'll use to handle this. And we could manually just write another method, just like we did below here. But if we just hover over this name of the method, we can see a light bulb here, which gives us an option to generate for us an event handler or an asynchronous event handler. So a synchronous or an asynchronous event handler, depending on the use case. So basically just a method to help us define what we want to do with our event. I'm just clicking the first one to have a synchronous event handler, which is just a method, and we can see by default here that this method also takes a change event argument. These arguments basically just contain some additional information about the event that is erased, and we could basically just use these arguments as a parameter in our methods. They are not necessary if we do not want the information that these arguments give us. We do not have to use them, but we'll see why they are useful just right here. So how I want to handle this event is that basically I just want, as soon as we type something in the input, I want to show it just below. For this reason, I'm just going to take a paragraph tag here, and I'm going to have a string variable below, naming it text, giving it an initial value of like an empty string, and I'm displaying its value here. By using the @ sign, I'm taking the value of the variable right here, just below the input tag, and I'm just gonna put all this part in a single div so that they are like in two different lines. And I would want them to be like, to have a bit space from above. For this reason, I'm just going to give them like a bootstrap class of margin 4. It just gives some margin on top, on bottom, in each side, basically, just a bootstrap class. And right here on the method, now, as soon as we input something on the input, so we're going to set the text variable to the value of the input, and for this reason we're using this argument. We can see here that this argument contains different properties, and if we use this value property here, this gives us the information of the value that's inputted in our input tag. We see an error here. This happens because this expression is basically an object. We can just simply cast it to strings since we're assigning it to a string variable. We'll also see this other underline here, which basically is the compiler is telling us that this expression could be null, and if we just put the exclamation mark on the end, we're telling the compiler that the value of the expression won't be null. Let me run the application so we see the result. Okay, here we have our form. As soon as we input something on the input, it is automatically, the method is being called, and on the text variable, everything that we input in our form is displayed just down below. So let me just now see like a mouse event. For this reason, I'm just going to make the code so that as soon as we hover over some specific div, we would want some text to appear or something. For this reason, I'm just taking a div element here. I'm making it a bit visible, so I'm giving it a border. So I'm making the border to be 1 pixel, solid and black. And here I'm just going to need to input, I'm going to need another variable. I'm naming it like div text. So as soon as we hover over some specific division, we want text to be displayed. Just using a paragraph tag again, and here I'm just inputting the value of the div text, and we need to specify the event attribute here. We have different mouse events that can be triggered that we can actually handle. I'm just using the onmouseover, and we'll handle this event with a handle mouse, or like a mouse over method. Then click over here and generate an event handler. As you can see, in this different event, we have a different argument than the argument of the other event. This is just because that this event take different kind of information about that specific event, which once again we can use if we want to, or if we do not want to, we don't have to use this argument. In my case, I'm just gonna display to the div text like a text of you are hovering over the div, just some text. Let me run this. And as soon as we see this div with a border, and as soon as I hover over with the mouse, we see this text being displayed inside the div because the method was triggered, and we updated the value of this div text variable that was inside the div, inside the paragraph text here. Now let's just see another event. Let me just take the example of the keyboard events. So we have different kind of keyboard events. I'm just gonna use the onkeydown event now. I'm just gonna show you how it works. So it's triggered as soon as we input something, as we press something in our keyboard. And for this demonstration, I'm just going to use this first div that we wrote above. So I'm just going to change the event handler here. So I'm taking an onkeydown attribute, and I handle it with the method handle keydown. As you can see, again, we have another argument, the keyboard event argument, that contains information about this event. For this case, I'm just gonna set to the text variable the value of the key that we have pressed. So to do this, I'm just taking the event. We have the different properties here, and I just need to use this key property to get the value of that key. You can see how this will work if I run the application. So now we are handling this event in this first input, and if I press something on my keyboard, we see this displayed. Then, so basically the last key that we have inputted, that we have pressed, we see displayed below. This doesn't only take numbers and characters, but also the other keys in our keyboard. Okay, so a couple last events that we'll see now are the focus events. So we have an onfocus and one onblur event, which basically just are triggered. The first one when we click on a form, and the second one when we click out of a form. Okay, so I'm still going to use this first form for this demonstration as well. So I'm just removing this event handler, and I'm using firstly on the onfocus event. Handle focus will be the name of the method, and on the same input I'm just also handling the onblur event with the method. I'm giving it a name of handle blur. So now let us just generate an event handler for each one of those. So we see yet again another argument that contains information about this event, but we're not going to use it in our case. So I'm just basically going to display to the text something like you are typing whenever we click on the form. Or basically the form is focused. That's okay, I would suggest. And for the handle blur method, let us change. So for the onblur event. Let us generate an event handler and just some different text there. You are not typing. You have clicked away. Let's see how this works. So as soon as I click on the form, we see this text. As soon as I click outside the form, then this other, so basically the onblur event was triggered. So when we click the form, the onfocus event is triggered and we see this message displayed. And then we need to click, actually not just hover outside the form, the input, but click outside the input to be able to trigger the onblur event. And there are different kinds of events that we can handle, but these were some of the types just to give you an understanding on how handling web UI events works. As an overview, data binding connects our application's UI with underlying data sources. With data binding, we can synchronize the state of our components with changes in data, resulting in a responsive and dynamic user experience. So we are in Visual Studio here. I have opened up a project that I've been working on in this series. So basically just a blank project. We're on the counter component here on the counter page. And I've just left a small piece of code from the previous video when we saw event handling. And basically we have inside the div element, we have an input. When we type anything in our input, we have specified an event handler here to basically just take the value of whatever we input there and paste it into this paragraph using this @ sign to display the value of the text field that we have specified below. And basically what we have seen here is a one-way data binding. So a one-way data binding occurs when the information or the data flows only in one direction, which is basically used to display data in the UI. So this happens when we take the data from a C# code or from a database and just display it in our UI, usually using this @ sign. And the difference between one-way data binding and two-way data binding is that in two-way data binding, the data flows in both directions. So basically, whenever a value changes in the UI, this also updates our C# code or the data in our database, and vice versa. Whenever we change something right here in the in our C# code, this will also update our UI. And to basically do this, we can just delete this code. We do not need this event handler here. We can use the bind attribute, and we can bind our input here to the text field. So just this line here will do the same thing that our event handler did. Whatever we write in our input, the content of our input will be binded to this text field. And then here below, we are displaying the text field value. Let me just run our project. So here in our counter page, if I type something and I'm going to need to click away, we see that the content of our input was binded to the text variable. And just like we saw there, the binding occurred on the onChange event. Actually, that's what happens by default, but we can change the binding event by just using the bind attribute, bind, then colon, and then event. We want the binding to happen on input, so as soon as we type any key in our keyboard, we would want the binding to happen and the value of the text to be updated. Let me just hot reload the project here. We refresh. As just after any character I type, we see that the value of the paragraph element just updates. Okay, one other concept that is worth mentioning is that we can basically choose to run a specific block of code after the binding happens. This would be very useful if we had a search box and would basically want to query in a database and would want some action to occur if we type something in our search box. To do this, we just need to use this bind after attribute, and here we can specify the name of the method that we want to be triggered. So let me just create a method. I'm just naming the method search here. We can create an asynchronous method here. We're just simulating a search, like we're searching something in the database. So async task, since we're writing an asynchronous method, I'm naming it search. I mean, that's the name of the method that we specified above. And we would want to basically, let me just take another string field here, naming it a result, giving it an initial value of an empty string. We're going to display it just below inside the paragraph tag. We're using the one-way data binding here with this @ sign. And when our search method is triggered, we want to update the value of our result field to, let's write a number here, 150 results were found. And we can also just use this task.delay method here to delay the execution of the following line with, let's say, 30 seconds. So since this is an asynchronous method, we need the await keyword before the method. Let me just run the project one more time to see how it works. Okay, so as soon as we type something here, after 30 seconds, we should be able to see the search method was triggered, and we see this displayed in our paragraph below. So that was data binding in Blazor. Please make sure to leave a comment if you have any questions. And just as a reminder, you can check out my C# ebook if you want to learn more about C#, or even if you already know the language, just to have a high quality reference guide at all times. We'll explore each render mode in Blazor, introducing them, discussing their usage, and we'll cover some examples in action. We'll start by using a default Blazor web app project, as we've been doing so far in this series. So let's get started. The first render mode we are going to see is static server-side rendering. By default, our Blazor components are statically rendered from the server. What this means is that as soon as a request is routed to our component, plain HTML will be rendered as a response from the server. And that's basically it. No state is maintained on the server. Static components are great when you do not need to handle UI events from users, but you only want to render some plain HTML. Most of the components in our default app are statically rendered, such as the home page, the weather page, or the layout component. But Blazor can actually enhance static components to make user interactions more responsive. For example, Blazor can enhance page navigation and form handling. Enhanced navigation in Blazor allows users to navigate between different pages or components within a Blazor application, while preserving the application's state. Users can transition between different views faster and smoother without full page reloads. What happens in the background is that Blazor intercepts the navigation and makes a fetch request to the server. Blazor receives the HTML from the server and then applies the needed changes to the DOM. Blazor enhances navigation by default, while forms can be optionally enhanced if you want to. Let us now take a look at streaming rendering. Streaming rendering allows your application to render parts of a web page or component as data becomes available from the server. This render mode is particularly useful when your page needs to perform some long asynchronous tasks before it fully renders, such as making a fetch request to an API or pulling data from the database. With streaming rendering in Blazor, the server starts sending HTML content to the client as soon as it's available, rather than waiting for the entire page or component to be fully rendered. You usually see some placeholder content like those loading ... messages on the screen. This allows users to start interacting with the application sooner, even before the content is fully loaded. When the async tasks complete, then the rest of the content will be rendered. Streaming rendering is used on our weather page. If you refresh the page, you'll see this placeholder content loading ... displayed. After a moment, the weather forecast data will then render on the screen. If we navigate to our code, we'll find that streaming rendering is enabled by applying this streaming rendering attribute. We can see below that we are specifying an if block. If we don't have the forecast data, the loading paragraph is rendered. Otherwise, we display a table with the weather forecast data. In our code block, we can observe an oninitialized async method, which is a method that is invoked when a component is initialized asynchronously. Here, we are simply simulating an asynchronous call using this task.delay method, and we're not making an API call or something like that. And then we're generating the data below. Once the data is generated, the component re-renders and the update becomes visible to the client. So as we saw earlier, initially we see the loading text displayed, and after about half a second the table with the data appears. Now let's explore how we can create fully interactive Blazor components capable of handling UI events from the browser. The two primary interactive render modes we have in Blazor are interactive server rendering and interactive WebAssembly rendering. Interactive server rendering manages UI events from the server via a WebSocket connection with the browser. Blazor transmits UI events to the server through this connection. Then Blazor updates the browser DOM with the rendered changes. Alternatively, Blazor components can utilize the interactive WebAssembly render mode for interactive rendering on the client side. In this mode, the component code is downloaded to the browser and executed client-side, using a WebAssembly-based .NET runtime. In interactive server rendering, the server always requires an open connection with the browser, which may result in server costs or some latency. The second approach, interactive WebAssembly rendering, initially has a longer load time while the .NET runtime is downloaded, but once it's done, it is cached, available for future use. And as a result, it offloads the entire workload from the server to the client. There is also a third interactive render mode that combines the strengths of the previous two modes. Interactive auto render mode. Components utilizing this mode are initially rendered from the server, while in the background the .NET WebAssembly runtime is downloaded. Upon completion of the download, the component automatically switches to WebAssembly-based rendering for future visits. So this page loads faster initially as it's rendered from the server, but afterwards the workload is entirely offloaded to the client and no connection with the server is needed. Our default Blazor project has only one component that uses interactive server mode, which is our counter component. On top of the page, we can see that we are using this render mode, directive attribute, and we're specifying the interactivity to be of type interactive server. If we go to our counter page, basically when we perform an onclick event on this button, we see that the counter increases, so the page is basically interactive. If you can go click on the page with the right of the mouse and go to inspect to use our developer tools here, I'm going to network. Let me reload the page, and here we'll see a WebSocket connection which has a status of pending. What this basically means is that a WebSocket connection is opened with the server and is active, and if I go to another page, if I wait a bit, we'll see here 16 seconds, 44, and basically this means that the WebSocket connection was opened for this amount of time. So whenever we use components that use the interactive server rendering, the WebSocket connection is opened and then it's closed when we're not using it again. If I'm going back to the counter, we'll see another WebSocket connection being opened here. If I go back to another page, the WebSocket connection was open for 8 seconds, for about 8 seconds. And our default Blazor project does not support the other two render modes, so the interactive WebAssembly rendering or the interactive auto render mode. So for this reason, we're going to need to create a new project. Let me just go to our menu above and create a new project. So we're going to create again a Blazor web app project. Click on next. I'm going to leave the name as it is and the location of the files. And here in this page now we have the option to select the interactivity type. So basically we have here the option to set the interactivity of our project to none, to server, WebAssembly, and auto. So basically the first one is the first render mode that we learned, which was the static server-side rendering with no interactivity at all. The second one was the interactive server rendering, then the interactive WebAssembly rendering, and then the interactive auto rendering. For this project, I'm going to select the interactive auto rendering. This project will give us the option also to check how the interactive WebAssembly rendering works so that I can show you these two types together. So I'm going to select this, and next we have the option to choose the interactivity location. What this means is that as it is per page or component, this means that we're going to need to set up the interactivity of each page or each component. We specified for each component one by one. If we set it to global, all of our components of our application will be set with the same interactivity, with the interactive auto rendering in our case. So I'm gonna leave it per page or component, and I'm gonna click on create to create our project. Okay, the project is being loaded. What we can see in our Solution Explorer is that basically here we have two projects. We have a server project and a client project. The server project contains all of our server code, and as you can see, this is similar to the project structure of our previous Blazor web app projects that we have been creating so far. And about the client project basically builds the code that's going to be downloaded on the browser, and then that is going to run client side on the user's browser. So we can just go and check in program.cs in our server code. We can see that the interactivity is set to, so it's enabled the interactive server rendering and the interactive WebAssembly rendering here. We can, if we would check what we have in our server project, we would see that if we go to pages, we will see that all of our pages or all of our components are as before, except the counter page or the counter component. This happens because this component was the only component that we had also in our previous projects that is interactive, and for this reason this is pushed down in the client project. If we check on pages, counter.eraser, we see that here we have the counter component, and basically all of the components or pages that we would want to be eventually run from the browser, we set these components, we place these components in our client project. We'll see that by using this render mode directive attribute on top, we have set the interactivity to be interactive auto. So basically interactive auto rendering. And I'm just gonna run the project firstly to see how this works. Okay, so we're in our home page. I'm gonna just inspect the page to open up the developer tools. And I'm going to network here. And if we try to go to our counter page, we'll see all of this stuff being downloaded, all of these libraries being downloaded. As you can see, this takes a while, but our page is actually interactive, the counter works. So what happened here? If we filter on WebSocket, we see that the WebSocket connection is opened, so we have a connection with the server here, but as well, if we go to WebAssembly here, all of these libraries from our client code are being downloaded, and the most important one on here on top, we see this .NET.native.wasm file, which is the .NET WebAssembly runtime. So this was being downloaded on the background, and now it seems to be downloaded. So how this works, as we explained before, let me just go back to our home page. We should see that the WebSocket connection here ended. It was opened for 56 seconds, for about 56 seconds. But now, if we go back to our counter page, the counter page is interactive, but no other WebSocket connection was opened. No socket connection is actually active here. This happens because right now the components rendering switched from interactive server rendering basically to interactive WebAssembly rendering. Now all of the UI events that the user triggers will be handled on the browser's side because we downloaded this .NET WebAssembly runtime. And this is how the interactive auto rendering works. I'm gonna go back to our project and I'm gonna go to the counter page and change the interactivity to be interactive WebAssembly so that you will see the difference. Let me just run the project. Okay, let me go back here and refresh. I think I'm gonna need to basically clear this storage data so that we'll see everything that's being downloaded there. So if I go to the counter page, the counter is not at first interactive. This happens because the load time of the component is a bit bigger in the interactive WebAssembly rendering because all of this stuff were being downloaded in the background. When all of these libraries and this .NET WebAssembly runtime finished downloading, then the component became interactive. So all of the UI events were handled then by Blazor from the user's browser. So this was actually the drawback of the interactive WebAssembly rendering, because at first the load time is a bit longer, but once everything was finished and the runtime is finished, then this is cached and the user events will be then handled faster from the client's browser. And if we actually check the WebSocket connection, we'll see no WebSocket connection was initialized because a server connection is not needed in this type of interactivity. To be able to create an application of any level of complexity, you need to first learn how to work with CRUD operations. CRUD stands for create, read, update, and delete, and these are essential operations in all applications. In this video, we will create the different components in our Blazor web app to perform these operations using scaffolding. We will cover various topics, including working with data in our Blazor web app, connecting our project to a database, understanding how form submission and validation work in Blazor, and much more. So let's get started. So let us just create a new project here. We're going to select Blazor web app template here. I'll name the application Blazor CRUD. Click on next, and I'm gonna let the interactivity to be a server, so interactive server rendering, and I'm gonna set it, leave it as it is, per page component and not globally. I'm gonna create the project now. Okay, the project is created. The first thing we are going to need is we're going to need to create a data model for us to be able then to perform the CRUD operations for that data model. So I'm going to the project directory here, and I'm going to add a models folder. Inside this folder, I'm going to add a class, a model class. Let's say a model class for student. Let's give a few properties to this class. Public int ID property. As always, a property for the ID, and then a property for the name. I'll set it to be nullable. So name. For the age, and one for the, let's say, a date time property for the birthday. Let's just leave it with these 4 properties. Right now, the Blazor actually gives us the option to create all of the pages or components to be able to perform the CRUD operations for a specific model. And we can do this by just going to the components folder, to the pages folder here, and I'm going to click on add a new scaffolded item. Let me go to Razor Components and click on Razor Component using Entity Framework. This is basically a very easy way and a simple way for us to get started with Blazor, even if we have some specific project and we could, for example, we could only need like a create page, an edit page, or one of these. We can select only one of these options here, but for this video I'm going to tell Blazor to create all of the five pages for our CRUD operations. I'm going to select the model to be student, the model that we created. Then I'm going to add a new DB context class here that we haven't created yet. Basically, this is just the C# class that connects our models to the database. Each time we create a new model, a new data model, we write its instance inside this context class. And then when we want to access some specific data or some specific model, we then again use the context to get the data from it. So I'm just gonna add a new context here. I'm gonna leave the database provider to be SQL Server. Click on add and let the Blazor do basically all the work for us. Okay, inside the pages folder, we have a student pages folder with all of our CRUD pages, or with our components. We have a create component here, a delete details component, edit and an index component here as well, and we're going to see what all of this do and how they work. But firstly, I'm going to create a database so that we store all of the data in it, and then we do this CRUD operations by accessing the database. So I'm going to go to View, Server Explorer, click here on Create New SQL Server Database. I'm going to need the server name of my SQL Server Management Studio. I'll take the server name here, input it here, and in the encrypt field here, I'm going to set the encryption to optional, or basically to false initially, so that we do not need to log into the database with a password or so each time when we access the database. Click on Trust Server Certificate, and I'm going to give a name to our database. Let's say Blazor CRUD Data. Click on OK. A database instance is created. In the properties folder here we have the connection string, which I'm going to need to take and paste it in the app settings.json. Basically, when we added our scaffolded item, Blazor created like an address here for the database, a connection, since we see here a connection string to be inputted there. But I'm just gonna substitute it with our database instance that I just created. So here we see the encryption was put to false, the database name is here, and then this connection string should already be in the service in program.cs file. So right now all that's left to do is to add migrations to our database. Adding migrations basically means that we specify our database schema. So I'm gonna need to go to Tools, NuGet Package Manager and Package Manager console, and we need to write the command add migration and the name for the migration. And basically what will be inputted in the database is the model that we created with its properties. This is the migration. Is basically, you can see it here, a migrations folder we created in our project. It's basically a C# class specifying a database schema. I'm just going to need to write the command here, update database. And our model will be then stored in the database with our specifications, and now we are ready to basically see how these CRUD operations work. The index page, if we can see it here, has, let's find the route, which is /students. So this is where we'll go first. And just go to /students. Okay, we have an empty table here. If I click on create new, we'll be redirected to the create page. Let me give a name here to, okay, Sean, the age 20, and I'm selecting a birthday. If I click on create, we see that we have a student basically was created in the database, and then it's stored. Here we have its name, the age, the birthday, which is not as well shown actually the date, so we actually don't need the hour here, but we'll modify it later. And on the end, on the last column, we have 3 links that take us to the details page with all of the details of the student. The edit page allows us to modify the data here. If I click on save, we see that the age was modified. And if I click on delete, here we have the option to delete this student from the database. So you can see that our CRUD operations are functional and work pretty well right now. We just will see
how each of these pages actually works in detail. So if I go back, we'll start with the index page. The main part of the index page here is the quick grid built-in component. Quick grid is a data grid component that is built in Blazor. Quick grid can access data from different kind of sources. Here in the items attribute, we are accessing the data from our DB context. Here on top of the page, we're injecting our context here, and we're giving a name of DB. And then we are taking the data from the context. This built-in component is very useful actually because it offers multiple features like sorting, enabling pagination to the tables, and much more actually, which we're not going to see all in this video. But let's just see. Below we see these property column tags that basically specify each column that will be inside of the table. We are in this property attribute here, we're specifying each property of our student's model. So the student's name, the student's age, birthday, and we are accessing this by accessing the data from the context. And below on the last column, as we saw, we are using this template column built-in component. We are just specifying some links to go to the edit page, details page, and to the delete page of that specific student using this student ID. And this is what we can do in this quick grid component is that, as we saw, the birthday was not specified as we wanted it to. We can basically add a format attribute, and let's say they set it to month, day, and year. If I run the project, this should be able to remove the time of the age, but we don't have a student anymore here, so let me create a new one. James Johnson, 40, pick a birthday and click on create. We'll see that in the birthday column we do not see the time anymore, we only see the specific date. Let me go back to our project. We can use properties to change how this column's name will be displayed. So birthday, we can set it to, if we would want to change it, let's say we can use the title property to set it to date of birth, let's say. We should see the column name will be changed here. Date of birth. And this is basically it for the index page. If I go now, let's just go to the create page. We can see that in our create page, we're using an edit form built-in component. And this built-in component is just substituting the form HTML tag, and it makes it much easier to connect the data of the form to a specific model. Here we have specified the method type to be of post, and we can see this model attribute that specifies the model the data model, which is student. Actually, this connects the data that will be submitted from the form. It connects it to this student property here. We can see that this student property here has an attribute above, supply parameter from form, which basically specifies that as soon as the data is submitted in the form, it will be bound to this property here. Then we'll use this property data here in this add student method below. Actually, we can see that the form had an onValid submit attribute as well, which was set to add student. So this is the method that will be invoked as soon as the data in the form was correctly submitted. So it was validated, the validation was also done correctly, which we'll see in a bit, and then the form was submitted, the method here will be invoked, and will basically store inside the context using this add method here our student that was submitted in the form. We'll save the changes to the database and then we'll navigate back to the index page. One last thing is the form name was specified to create here in this using this form name attribute, and this is necessary in cases that we have multiple forms in our page, and when we basically have a property below here, we can specify the form name inside this property so that the data of each specific form will be bound to the correct property. In our case, we do not need this because we only have one form, but if we would need to, we could use it. The last thing we see, we have an enhance attribute in the edit form component. This basically enables enhanced form handling in Blazor. This is something similar to the enhanced navigation that we saw in a few videos back. So when a form is basically submitted, the Blazor intercepts the form submission, performs a fetch request to the server, and gets a response from the server basically, and performs the needed changes in the DOM. It's basically a feature that makes the form more interactive and enhances it. So we can see, basically we saw also before how the form worked, but let's just see now what we have inside the edit form. We have some divs. In each div we have a label for the input. We have, in the first case here, we have an input text built-in components that only takes text input, and its value is binded to with this bind value attribute is binded to the student.name, so to the name property of the student model. And in the second case, we have an input number component, then an input date component depending on the data that we are inputting there. This is bounded to the specific property of the model, so that then all of the data that will be submitted by the form will be easily bound to our property, to our student property here below. And we can see basically that we have on the end of each div, we have a validation message component here. We saw on top also we have a data annotations validator and a validation summary component. What these now do is that they validate the data so that the correct input will be submitted there. To be more specific, let me show you how this works. If I go back to the models class that we created above, we can input restrictions for our properties here. Let's say we can, using data annotations, I can put the name to be required. And let's say I'm gonna put the age to be in a range within 18 and 35. So students have to be in an age between 18 and 35. Then this data annotations validator will display an error message on the end of each input, and also on top of the page a validation summary with all of the errors that occurred. So let me just run the project so that you can see how that basically works. Okay, let's create a new page, let's create a new student, and let me put a name like Tim here. Let's put the age to be 36. Let's input a birthday, click on create, and we see that the form was actually not submitted. We see the error message here. The field age must be between 18 and 35, just like we specified it. And we see on top of the page a summary of all of the validation errors that occurred. If I correct it to be 34, let's say, and click on create, this student will be stored in a database, and then we can see it in our index page. This was actually quite useful, but one thing missing is that we would want actually to validate, for the application to validate the input as soon as we click out of the input form. We can enable this in Blazor, but we're going to need to make our component page interactive. How we'll do this? We just need to specify the render mode on top of the page to be interactive server, since we created an application that allows interactive server rendering. And if I run the application now, it will be more interactive, and the validation will happen just as soon as we click out of the form. Let's just try it one more time. Let's set it to Peter. If I put age 15 and I just click away of this input form, we'll see that this was validated, and we see that the age field must be between 18 and 35. We can actually see in the first input form that we see a green outline, which basically says that the data inputted is correct. And this is what we'll see also if we fix the age here. We'll see that the form is outlined with this green color here. Let me input a birthday here and create the other student. So we have 3 students now. Let's go to the delete page. So on top of the page, we have like this big header asking us if we really want to delete the student. And here is displayed if the student is not basically loaded yet. We see this message. If so, we'll see all of the data of the student, and then an edit form again, an edit form component to basically delete this student. In our code block here, what we see is that we see an ID property which has this attribute supply parameter from query. What this does is that this ID property gets the value from the URL. When we go to that URL, let me just go to the delete page of the first student. In the URL, we see that we have an ID equal to 2. And what this does is that this property will get, in this case, this ID property will get the value from the URL. And then we're going to use it down below. Actually, we have an initialized async method, which is a method that is initialized as soon as the component renders. We are basically going to find the student by checking through our database for the student with that ID that we got from the URL. And then we're going to use this student data here, firstly to display the name, the age, the birthday of the student. And then we're going to use it down below here in the edit form. If the form is submitted, when we click to the button here, this onValid submit method will be triggered, the delete student method. And here we basically go to the context and remove that student, save the changes to the database, and go back to the students, to the index page. Let's just go to the details page now. The details page as well has an ID property that gets the value from the URL. Then as soon as the component renders, this uninitialized async method is called. It loops through basically the student with that specific ID in the database, and then it displays the data to the users, as we can see here. Pretty simple. The edit page, then basically it is similar to our create page. We have this edit form built-in component, but the only difference is that the data is already filled in the inputs of this form, because as soon as the component is rendered, a database check is being done to find the student with that ID that we got from the URL here. When it finds this student, then its data will be inputted to each input here, and we can then make a change, make a modification to any of the input that we would want to. If we click on save, then the update student method will be triggered, which we can see here below. Basically, the first line basically just helps the context to track the changes in the context, so sets the state of this entity to modified, and then the changes will be saved to the database. If an error occurs, will be redirected to a not found page, otherwise will just then be redirected again to the students page here. Let me just show you how the edit works. So if we click on edit, we see that the input is already filled with the user's data with the ID of 2 actually in our case. If we make any modification here and save the changes will be saved and we are still redirected to the index page.
Now, after completing the Blazor fundamentals, make sure to watch my food menu web app project in Blazor. It's a very simple project that will help you practice and reinforce what you have already learned. I really appreciate you watching this far. If you got value from the video, don't forget to like it or subscribe to the channel for more content. Thank you as always for watching, and I will see you in the next video.